So today's lesson is about linear factors and zeros. This is part 1 of 2. We'll have our next part for you all will be Wednesday, since we have that Monday off of next week. Our objectives for today is to identify the zeros of a function when it is both factored and not factored. And then our other objective for today is to construct a function given the zeros of a function. Right. This will be demonstrated on the exit ticket at the end of class, at the quiz in a couple weeks, and the unit test at the end of the unit. Let's go a little bit of an overview before we actually move into what we're going to be teaching. We have our definition up here. We'll go over the definition a little bit, talk about it. We'll do a little bit of a review right here on how to factor things. And then we'll go into our problems that are actually about finding the zeros and then going in reverse to get our functions. All right. At the very end, you'll have your you do section and then your exit ticket. Let's a little overview. Let's start with our definition. This is just an example problem right here. There's a couple of terms that we're going to go over right now, which is factors, zeros, roots, and x-intercepts. Those are the 4 main words that we're going to be going over. The factors are pretty much just the parenthesis parts. So whenever I have something in factored form, I have it always broken up into all the different parentheses. All right. So like x minus 1 is a factor. Whatever's inside the parenthesis of my function is the factor. For each one of those factors, if I take the opposite of the inside, I get my zeros. All right. So the 1 is my factor. The opposite of a positive 2 is a negative 2, and so that is my 0. The opposite of this negative 3 right here is a positive 3. So that's my 0 of the function. That's what that means. I like to think of it as what I would plug into this to make it 0. So if I plug in 3 right here, I get 3 minus 3, which is 0. If I plug in negative 2 right here, that makes it 0. If I plug in 1 right here, that makes it 0. So that's why we call it the zeros of a function. What we're more used to saying and seeing is root/solutions. We mostly call these problems solutions in our past. We're going to add on the little term roots as well. We'll see what those more mean later on. But again, solutions is the same thing as what we usually do. It's as if we took this function right here and we set it equal to 0. And then we solved like we usually do by setting each piece equal to 0 and then solving. And then finally, we have our x-intercepts, which we know what those are. They're where the graph hits the x-axis. So we have 3 different places where it hits the x-axis on this one. Now, a key thing to notice is that all 3 of these terms have the same answers. And that's because really, these 3 vocab words are really talking about the same idea, where they are at 0. Where each one of these functions are at 0. So what we're going to do to kind of show that is we're going to highlight each one of these. Let's go with green. So x-intercepts, root/solutions, and then zeros are all really the same thing. Where's my highlighter? They're all talking about the same thing, and that's just the fact that wherever my function equals 0. Wherever my x-intercepts is just where my y-axis or my y equals 0, all that good stuff. Okay. So in the end, these 3 terms are interchangeable, really. They're all talking about the same thing. They just have a different part of what they're talking about as compared to it. Are there any questions on the definition? All right. Doesn't seem to be any questions, so we're going to go down to the we/you do review. What I would like everybody to try and do is see if they can factor both of these functions right now. I'm going to give you about 4 minutes to do that, and then we will go over how to do it after that. All right, so 4 minutes starting whenever I can get my timer out. Get it down to the right time. 1, 2, 3, 4. 4 minutes starting now to try and factor both these. I left a hint for both. This one you should factor to GCF. This one you should factor by grouping. Try it out. That's my first step for number 1. Good. Someone said it. Find the GCF. What is my GCF for this one? It's 1 correct answer. Let's see if I can get anybody else to tell me. That's 2 correct answers. So I can get a couple more. Perfect. 3 for 3 so far. Let's take that out. So I'm going to go up here, insert equation. So I get the nice little text boxes. I go y equals, I have my x out front. If I take out an x from here, I'm taking 1x away, so now I have an x squared minus 2x minus 15. Now that I have this factored out my x, what method can I use to factor this inside part? What would my next step be? Good, I got 1 correct answer. Anybody else know what type of method I would use? What my answer would be? Any ideas? Class is sleeping. All right, so just like we did this morning, we're going to use our x method. Can anybody explain to me how I use my x method? How do I use my x method? What goes to the top, what goes to the bottom? What should my final answer be? Good, 15 on, not 15, but negative 15 on the top, negative 2 on the bottom. Perfect. Then what should I do? Perfect, 3 and negative 5, or negative 5 and 3. Again, order doesn't matter. You can do it in whichever order you want to do it in. And so right here, what I would get, go new equation, I go y equals, leave the x out front that I already had, and then x plus 3 times x minus 5. And that would be my factored form for this one. All right. First thing I did was I factored out my GCF that I noticed was in there, and then I factored the 2 completely. All right, using my x method for this one. Are there any questions on how I factored this? All right, let's ask a different question. What are the zeros of this function? Anybody tell me what some of the zeros are for this function? Taking this one step further, we did what we already knew how to do. We're going to add this part right here. What are some of my zeros for this function? You can tell me. Remember, no one else will know what answers you give unless you. Negative 3 is one of them. Good. I got a negative 3 as one of my zeros. Anybody else give me another one based on the fact that it's negative 3? Good. That's another correct answer. I got another one of 5. Another one gave me negative 3 and 5. I'm going to tell you now there's one more. I have someone just told me that last one. Does anybody else know what that last one is? Not quite. Close. Close. It's a little tricky, right? Because it's not like the other ones where I can just take the opposite number. But what if I rewrote it like this? If I rewrote it like that, what would you think the 0 would be? Another correct answer, good. I want to see if everybody can tell me what they think the answer should be based on looking at it like that. What should my 0 be based on the fact that I have a -3 and a 5 right there? What should my 0 be? See if I can get a couple more people. I think this is a good question to make sure that you drill it in your head, because a lot of people will end up getting this right here wrong on a test or a quiz. So I want to make sure that we all remember what this is. So remember, zeros are just a number that I plug into x to get 0 out. So if I plug in -3 here, this will turn to 0. If I plug in 5 here, this will turn to 0. What do I have to plug in for x right here to make this 0? It's a little weird to think about sometimes, these ones. It's the correct answer. So my answer is 0, which for a lot of people feels really awkward. Right? But whenever I just have an x by itself, we aren't going to see it like this. We're going to see it like this. We should know that it's just a 0. Another way to look at it is if I set each piece equal to 0. Right? So I can go x equals 0, x plus 3 equals 0, and then x minus 5 equals 0. And then I would solve those. I would get it. This one's already solved, so I already have my 0 there. This one, I'll move the 3 over, so I'll get -3. This I'll move the -5 over, so I get +5. And it's really that simple. You don't need to overcomplicate it more than that. Once it's in factored form, I just take my opposite numbers, and then if there's just an x by itself, I put a 0. Are there any questions on that? And again, if you are completely lost on this, that's something I would also like to know. You're like, man, I'm not getting this at all. Thanks for telling me. So again, we started off our process. We were asked to factor this. So we factored it down to this right here. That was our first step. That was the end of the problem that it actually asked us to do. Then I asked you even further to find the zeros. All the zeros are the numbers that I can plug in that'll make it so that it's a 0 inside here, or inside here, or inside here. So what I can do is I can set each parenthesis equal to 0. So I might set my x equal to 0, x plus 3 equal to 0, x minus 5 equals 0. And if I were to solve these equations, x equals 0 is already done. If I move the 3 over, I get x equals -3. And then the last one, I get x equals 5. So all I'm doing is factoring it, which we know how to do from last semester, something we've already done. I'm setting each one of my factors equal to 0, which is something we also did last semester. And then I'm solving, which is also something we did last semester. The only new part is really calling it a 0. Right? Everything else we've done so far is the same as something we've done before. The only change is with the word we use now. Instead of calling it a solution, we're calling it a 0. All right. Does that kind of help you with your understanding, or do you still need more of an explanation? So let's go on to A over here right now. Who can tell me, if I can click on the right spot, how to group? How do I factor by grouping? Maybe explain that to me. Right. Some of you guys need to drink coffee in the morning. Perfect, I love that explanation. Perfect, perfect, perfect. I'm gonna say some of the answers that I got. Cut the problem in half and then factor it with the X method. Someone said put parentheses around 3x and negative 12x and over 2x and negative 8. Someone else said group the first two terms and then you group the last two terms. And someone said factor GCF if needed. Those are all correct things. So what I like to do is I like to be a little bit more fancy, and I'm going to put a box around my things. So I put a box around my first two numbers, and I put a box around my second two numbers. There we go. And then I'm going to factor each one of those separately. Factor out that GCF. So what's my GCF of these first two numbers? Who can tell me? What's my GCF of those first two numbers? Perfect. Let's see if someone else. Good. Got two correct answers. I'm going to put that 3x quantity squared is my greatest common factor. I can see that because my 3 and my 12 both have a common factor of 3. And then they both have at least 2 x's. And so if I divide this by that, I end up with 1x left over, minus 12 divided by 3 gives me 4. And all the x's cancel out, excuse me. So I'm done there. Then I'm going to do the same thing over with this one over here. Who can tell me what the greatest common factor between these two are and what my final solution should be? What's my greatest common factor and what should be my leftover? It's one correct answer. Two correct answers. Same type of people that have been answering this whole time. Close. Remember, they both have to go into it evenly. Perfect, perfect. Good, so I'm gonna put that up there, plus 2 is what people said, the common factor of 2, and then I get x minus 4 left over. Now what I do, it's a little tricky part, so I can kind of think about it as pulling that x minus 4 out. So what I'm gonna do now, so I'm gonna get the y equals part that was already there. I'm gonna get the x minus 4 part at the front, and then I'm gonna put together the things that are left over, the 3x squared and the plus 2. And that is my factored form. Are there any questions on that? Now we're going to do the same question as I asked before. What are the zeros? Anybody tell me one of the zeros? Correct. Getting a lot of one correct answer. 4. Does anybody know what any of the other zeros would be? I'm going to tell you now there's 2 more zeros. They're a little tricky. I'm liking some of your guys' answers because you're taking what we know and kind of like what we've learned before, kind of trying to add it on to here. But this one's a little tricky in the fact that this isn't truly fully factored form. Because of that, we can't exactly simplify it fully. But what we can do is just like we did over here, set each piece equal to 0. So I can go x minus 4 equals 0. And then I can go 3x squared plus 2 equals 0. Oops. Plus 2 equals 0. All right. So now we have that solution. That one's checked off. That one's already done. What we need to find is the 2 factors from here. Now we have learned how to solve this equation right over here last semester. We're so good, we can still do that. It's a little bit harder than what we're used to, but we can do it. So what we got to do, I'm going to rewrite it over here. And this would be a good thing to write on a separate piece of paper to have down. It's kind of hard to actually write this inside Google Docs, show all the things that we're going to do. So if you have a piece of paper next to you, I would like you to write this down somewhere. It'd be very handy to have. So please write this down while I'm going along with it. So just like we usually do with this problem, so we're going to solve this by getting the x by itself. To do that, we got to go in reverse PEMDAS. So we first get rid of this +2 by subtracting 2. And we end up with, for now, 3x squared equals -2. My next step in reverse PEMDAS is to get rid of multiplication and division. So I divide both sides by 3, divide both sides by 3, and I end up so far with x squared equals -2/3. Now, can anybody tell me how I get rid of a squared term? How do I get rid of that squared? Perfect, 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 good. I square root it. Now there's something I got to remember when I square root a square. Can anybody tell me what I got to remember when I square root a square? What do I have to add? Ooh, that's a correct answer. 1 for 1 so far. Does anybody else remember what I add? Now we got to think all the way back to like 2 months ago. All right, well, I'll just put it on there since someone does have it. I got to add my plus or minus. So whenever I square root a square, both the positive and the negative squared will be the same thing. And so plus and minus work for this one. Now there's one other step we have to do with this. Does anybody remember that one last thing that we can do to simplify this thing right here? Anybody remember? Try and think back. That's a correct answer. I got one correct answer. Does anybody else remember? Same person who got the other stuff right too. Killing it. Does anybody remember what else I do? Can anybody tell me? Other than the person that's already told me the correct answer. Remember, in math, the more I try and answer something, even if I'm wrong, the more my brain grows, the better I get at math. So if you're just sitting there waiting for me to give you the answer, you really aren't growing as much as you could. So try and give me the right answer. And if you get it wrong, now you know that it's wrong. If you get it right, then now all of a sudden you know that you're right. Who thinks that they know? Who's got some type of guess on what we do? All right, there's one more answer. I'll take that. X equals plus or minus, and then whenever I have a negative in there, I can change it to a special thing called an I, our imaginary number, 2/3 I. Right? So whenever I have that negative inside of a square root, I can change it to an I. So now our zeros right here will be 4 and plus or minus the square root of fraction bar 2/3 I. So those would be my 3 zeros. Now this is about as hard of a problem as you will see for these type of problems, but it will be asked of you to do this at some point. So are there any questions on the process we've done so far? Now I'll remind you to please make sure you wrote this down somewhere because it's a good thing to have this process to look back on. So my two zeros are the square root of 2/3 I and negative square root of 2/3 I. Remember, plus or minus means there's actually two things. And again, I only do the I when I have that negative right there. So the negative right here decides that I have an I. Whenever I have a negative inside of a square root, I put my I on the outside and get rid of the negative. Remember, I is equal to the square root of -1. This process is something that you will do every once in a while when you're going throughout the process. It won't happen too frequently, but it will happen enough that it is important for you to have it written down somewhere. So again, if I was listing this out and you don't like how this looks, you could also write it as 4 square root of 2/3 I and negative square root of 2/3 I. Remember, that's a negative sign. Let's make it look a little better. Negative. All right, those are my three solutions. The positive one, the negative one, and then my 4. Any questions about this? Hopefully this doesn't look fully foreign to you because we have gone over how to do all of this stuff over here and all this factoring stuff last semester. Now, it might be kind of fuzzy right now since we haven't done it in a while, since we had that big old break for winter and all that. But it is still in there, hopefully. The only new part is calling it a 0. All right, so I'm going to move on in a second. I'm going to give you about another 10 seconds to write this down if you have not already written it down. Then we're going to move on to the new We Do problems. All right, clear all drawings. Get out of here. We're going to move down to this We Do section. We have 3 problems that we're going to do. Problem example 3 and example 4 are definitely a little bit harder than example 1 or example 2. Example 2 is actually very simple. It's what we've already been doing. It's when we're given a function in factored form. It's already factored for us. And I'm just trying to find the zeros. To do that, I set each of my parentheses equal to 0. So x plus 2 equals 0, x minus 1 equals 0, x plus 3 equals 0. And then I just solve like usual. Subtract 2, add 1, subtract 3, get my numbers. Again, all I'm doing is when it's in factored form, when I've already factored it, I set each thing equal to 0, and I solve. Are there any questions for example 2? All right, then we're going to move on past example 2. We're going to move into example 3. So we're going to write out a polynomial in standard form with the zeros. So before a second ago, we were doing our first objective where we were finding our zeros when it was factored and not factored. Now we're going on to our second objective which is to take our zeros and go backwards with it into our standard form. To do that, we are going to take each one of these zeros and we're going to make it into a factor. To do that, all we do is plug it into our x minus number. All right. We go x minus -2, x minus 2, x minus 3. That's it. Now this looks a little weird. So if you don't want to write this right here and you want to go straight to x plus 2, you can do that as well. And again, all I'm doing is taking my 3 zeros and then making them into factors. So same process as what we saw in our original right here. Right? So we had our factors right here. We made them into zeros. Now we're just going in reverse, putting it back into this function right here. X minus our number, x minus our number, x minus our number. Does anybody have any questions about that right there? That process of plugging in our number in reverse, putting it back into our function. If you are having problems with this, the next portion will look really confusing. So does anybody have any questions on how we did this? Right. Yeah. So again, don't try and overcomplicate it in your brain or anything. All we're doing is we're taking our numbers, our zeros, -2, 2, and 3, and I'm subtracting it from x inside of my parentheses. Right? So I go x plus 2 since I had a -2, x minus 2 since I had a +2, and x minus 3 since I had a +3. Just taking every number and then subtracting it away from x inside the parentheses. That's all that it really means to go from a 0 to a factored form. Just subtract it from x. Just subtract it from x. Just subtract it from x. All right. Once I do that, then I'll have to do some foiling to be able to simplify it. Right. I foiled these first two for myself. If you would wanted to, you could foil any set that you want. Right. The order of foil doesn't matter as long as you end up foiling everything. So I ended up foiling these two first. I made it really easy. So you can, I know that some of you all do not like FOIL as a process. You like to use your other methods like the box method I saw, as well as the distribution method. However you FOIL or however you multiply two monomials, that is fine with me. I like to FOIL, so I'm going to show foiling right here. So I multiply these two, multiply these two, multiply these two. And then I just multiply them together. X times x gives me x squared. X times -2 gives me that -2x. 2 times x gives me 2x. And then 2 times -2 gives me a, that's not a good x, -4. Right. So again, I'm foiling these two together, and then I simplify. When I'm simplifying these two go away, and I end up with x squared minus 4. And I put that right down here. So that was my first step, or kind of second step of simplifying. All right. I foiled these two together, and now what I'm going to have to do is foil these two together. Before we move on to foiling these two, are there any questions on how I foiled this or anything we've done so far in this problem? All right. And we'll FOIL this out right here. FOIL these two together. We'll FOIL these two together. Multiply these two and multiply these two. Actually, let's show you one of the other methods that you can use to FOIL. So another way I can FOIL is I can use what's called the box method. Kind of make a tic-tac-toe box. At the top here, I put my first terms, x squared and -4. Then over here, I put my other two, x and -3. And then I multiply each box together. X squared times x gives me an x cubed. That's not a cube. -4 times x gives me -4x. X squared times -3 gives me a -3x squared. And then -3 times -4 gives me that +12. Then I just put everything together in order. X cubed minus 3x squared minus 4x plus 12. And that would be my final answer, because now I'm out of factors to FOIL in. Are there any questions about our problem? We just finished it up. We just got our final form by FOILing these two together, adding them all together. So this would be my final answer. Are there any questions about that answer or any of the process that we went through? Again, I want to repeat. This is always something we should think about. If you are completely lost and you're like, man, I don't understand anything about what we've done, that is something that I do need to know. Yeah. So to get my last problem right here, I take these two things right here, and I put them inside my box. Now you don't have to use this method if you don't want to. You could use the FOIL method. Do that again. I was just showing you another method. But in the top two, you put your first two terms. On the left side, you put your other two terms. The other one's inside the parentheses. Then you just multiply everything together. So x squared times x gives me x cubed. X squared times -3 gives me -3x squared. -4 times x, -4x. And then -4 times -3 gives me that 12. Then I just add everything together. Right. X cubed minus 3x squared minus 4x plus 12. For my final answer. Are there any questions on that? Does that explain your question as well? Or do you want me to explain some more? So the numbers in the box then can go in whatever order I want. I could have also set it up with x squared and -4 on the side. And then the x and the -3 up top. Just as long as they're together. So I look at them as kind of connected. So the x squared and -4 are together, the x and the -3 are together, because they're together in these little parentheses over here. Then I just add them all up. And I put them in this order over here, because I always go from my highest power to my lowest power. The cubed is my highest, squared is my second highest, then it's x, then it's my 0 power. Are there any questions about this? Because this is a main portion of what we're going to be learning about for this section. So we're going to move on now to our next thing. Next problem right here. Example 4. This one's a little more complicated because of the fact that it adds the 3i and the negative 3i to my zeros. The beginning part is the exact same no matter what. Right? All I'm doing is replacing my 3i with it. All I'm doing is subtracting it away, subtracting negative 3i, so I get a plus 3i, and I subtract my 4. So all I'm doing, again, when I'm setting up my factored form, is to make all of these right here. Right? Plugging it in, plugging it in, plugging it in, subtracting it away from x. Technically, with what this problem is asking for, write a polynomial in factored form, this would be my final answer. Right? If it's just asking you to put it in factored form, that would be my final answer. Right? Because that is in factored form. If it asks you to make it into a, like this one, standard form, this would be your answer. Right? So you got to make sure you're looking at the problems. I think that a lot of people got one of the problems on the homework wrong, that have taken it from yesterday and everything, because they tried to do it all the way down to this part when it just asked for that factored form part. So make sure you're paying attention to the question. Factored form means that I'm leaving it in this form. Standard form means that I'm simplifying it. Now let's go over this process, because I think there's a key part that a lot of people have forgotten from last semester with this x squared plus 9, how I got that. All right, so I foiled these two together. When I foiled these two together, I did my first two, my last two, my inside two, and my outside two, and I multiplied all those together. Excuse me. X times my x, my first one gives me x squared. X times my 3i gives me my plus 3i x. Again, this is one of those things that would be good to write down so you have it to work on, all right, to look at if you ever have a problem like this. These two multiply together, I get negative 3i squared, or negative 3ix. And then finally, I get negative 9 I squared. That's not a good I. All right. Are there any questions about how I did that just now? How I foiled these two out? Give you a second to write that down if you haven't already. All that good stuff. Now I got to simplify this. That plus 3 and that minus 3 cancel out. Someone asked a great question. How do you determine which ones to foil? In what order? I know because of experience which ones to foil first. One good thing to know that you should all be able to start realizing is that when we have two of the same thing with opposite signs, like 3i and 3i, but one of them's minus, one of them's plus, those middle terms are going to cancel. And so it's going to be easier than some of the other ones. So that's what I know is going to happen. Some of my stuff's going to cancel whenever I have these opposites. And so that's how I chose those two first. Other than that, like down here, it doesn't actually matter which one I chose first. It would have just ended up being the same thing in the end anyways. I will say something that I like to do most of the time is save my bigger number for the end. That means I'll have bigger numbers throughout, and so it gets a little bit harder. I would say use your smaller number first. I didn't do that in this case. That's a good little thing to kind of, if you're trying to make it a little bit easier for yourself, good little thing to follow. But again, these two cancel out. Let's go back to this. I get x squared minus 9i squared. Can anybody tell me how I went from here to x squared plus 9? Let me remember why that's true. What do I have to do to this one over here to make it this? So you may remember what I can do with this I squared to change it up. You may remember. Not quite. It's a good guess though. Two people have given me some good guesses with square root. Not quite though. Let's rewrite I squared as something though. What can I rewrite I as? What can I change I to? What does I mean? Kind of like that answer. I means imaginary number, which is also the same as my imaginary number is the square root, just like someone told me, of -1. So that's what I is. Now what if I square both sides? If I square this side and I square this side. What does this become? It's one correct answer. Can anybody else tell me what the answer is? Perfect, the two correct answers. Anybody else? So when the square root of a square, those two cancel out. I'm just left with the -1 over on this side. And so I squared equals -1. It's a weird too. Let's redo that too. Gotta stop bouncing my foot so much. Too much copy. All right, so I got my I squared equals -1. So now I can plug that back into my equation up here and replace that. So x squared minus 9 times -1. And so I get x squared plus 9. And that's where that plus 9 comes from instead of the I squared, all that. I would put a star next to this because that is something that is something that we learned last semester that it's very easy to forget because it doesn't come up too often. But I will keep trying to remind you that I squared equals -1. This is really important right here. This will come up more when you talk about conjugate bases and everything, but specifically this -1 part, make sure you remember that. Are there any questions for me about what we've done so far, that first step of foiling this out? All right. We don't have infinite time, so I'm not going to go over how to FOIL all of these steps out. What I am going to show you how to do is to FOIL this one right here. All right, so I'm not going to show you how I did this FOIL right here, thinking that most people can do that. What we're going to talk about is this FOIL right here. So whenever I have a multiple polynomial right here, all I got to make sure I do is connect all my little lines. This is one connection. This is two connections, 3, and 4. And do the same thing with my -4. Okay? So that's really all I'm doing with the multiplication is I'm multiplying each one of my pieces by the other one over here. 3 and 4. for a total of 8 little lines. Right? When I multiply these together, I get these numbers down here. And then I just combine my like terms of the cubes, the squares, and the singles. Right? So again, when I'm trying to multiply these, I connect all of my different lines to each one of the things. Do the same thing for the other one, making sure that everything is connected between the two sides. Are there any questions on that? And I want to remind everybody that this is stuff that we have seen before, this foiling part and everything. We know how to foil. We're just upgrading it and making it a little bit harder, right? Because now we're making it more robust, a little bit stronger of a thing. All right, but all of you have seen how to foil before. You all know how to do that. We've seen how to foil this right here before. This is all stuff that's not actually new. It's just a step up from what you're used to. And so you can all do this. You put your mind to it. Are there any questions on example 4? All right. Let's move down to the you do practice down here then. We have 6 problems right here. I will say you probably don't need to do all 6 problems. What I would rather you make sure you can do is to make sure you can do at least number 1, and then make sure you can do at least one of these 2 down here. All right. For your exit ticket, that's what you're going to be asked to do. So make sure you can do at least number 1 up here, one of these 2, and then make sure you can do at least one of these 2. Once you've shown that you can do that, you feel confident and all that stuff, then you should start on your exit ticket. Once you're done with your exit ticket, you may go. So again, I would focus on probably number 1. Do one of these 2 things, and then do one of these 2. If you have any questions, as always, I'll be here. If you want to check your answers, I'll be here. Remember that the exit ticket is how the school does attendance, so make sure you're doing that as well. Good luck.